Fertility Friday on Ireland's Classic Hits Radio with SIMS IVF. Find information and resources that can empower you on your reproductive journey. Fertility testing available with 6 clinics nationwide. See sims.ie.
Graham Coull is with us today, Group Scientific Director at SIMS IVF. Welcome, Graham. Thanks for coming back on the show.
Thanks, Trina. Thanks for having me back.
So we want to look at today on our fertility mini-series, we want to look at embryo selection and how the whole process works.
Well, look, our basic tools for embryo selection are looking down the microscope, and it's more or less a beauty contest. We pick the prettiest embryos that we can find, and that's certainly been the way that things have happened for a long, long time. Thankfully, nowadays, we've got additional tools, which I'll hopefully might touch on later on. But the original ways that we select embryos is the stage of development on certain days, and then how the embryo is forming and what the quality of that embryo is like. So there's essentially two different types of embryos that we transfer. We transfer cleavage stage embryos. Those are embryos up to day 3 development. At that point, all the cells are pretty much the same size as each other in a good quality embryo. And what we're looking for is on day 2, if we're going to do a transfer on day 2, we would be expecting embryos to be between 2 and 4 cells. And on day 3, we'd be looking for around about 8 cells, maybe even a little bit more cells than that, depending on the time of the day where we're doing the transfer. However, nowadays, I would say 95 to 98% of our embryo transfers don't happen on those early stages. What we do is we actually hold on to the embryos for an extra couple of days until they form what's called a blastocyst, which I'm sure a lot of patients would have heard that. Most clinics in Europe would be working with blastocysts now rather than day 3 or day 2 embryos. And the reason we do that is that many, many embryos will make it to day 3, but a proportion of those just don't develop any further than that. So by holding on to them for another couple of days, we get this extra additional information on the development of the embryo. Right. And it's the first time that there's any differentiation in the embryo. So up until day 3, every cell is essentially the same as the one next to it, and the only signals that are really going are divide, divide, divide. On day 4, later on day 4, what happens is all the cells start to squeeze down against each other and form a single cell mass. That's something called a morula. And then on day 5, hopefully what we see is something called a blastocyst. And as I say, that's the first time there's differentiation between the cells. There's something called an inner cell mass, which is a big bundle of cells, and cells that inflate like a big beach ball called the trophectoderm cells. Now, the inner cell mass are actually the cells that go in and form the baby. So what we're looking for is a nice, big, tight, clear bundle of cells and plenty of cells in that bundle. And obviously, we want a nice, healthy bunch of cells there if we want to have a baby in an ongoing pregnancy. And then the trophectoderm cells, which are kind of inflating like a big beach ball, they're the cells which will implant, become the placenta, the membranes of the pregnancy, and the support structures of the pregnancy. So again, we're looking for a nice, sort of even amount of cells there. The correct development for the embryo is on.
There's so much involved in the lab, isn't there? It's not just a case of egg retrieval and then a few days later everything goes back. You're constantly watching for development. 100%.
And that's where the technology has helped us in recent years now. So for about the past 7 or 8 years, I think we've had, since all of our clinics have had time lapse. So that's they're very nice incubators, but what they also do is they take images of the embryos every 10 minutes and we can play that back as a video, and we can observe the embryo for the whole length of time. You can imagine traditionally we've taken the embryos out of an incubator, looked at them for as quick as we can because we don't want to keep them out of the right environment, and then pop them back into the incubator. So we were probably making judgments in the past when we've only seen, in total about 2 minutes of that embryo's development over 5 days. Now with the time-lapse scopes we have now, the embryo scopes, we can see that development of the embryo the whole way through without disturbing it. So we're looking at everything and every day, making sure that everything happens at the right time. And that in itself is laid on to other things like things called morphokinetics. So we know that an embryo should divide, become 2 cells within a certain time period, should become 4 cells, should become 5 cells. All the different cell divisions should happen in a certain time range. So we mark up all those things. And again, that gives us a score that's independent of how pretty the embryo looks as to how viable it might be. So if things happen at exactly the right times and that embryo gets a high score, there's things that have kind of gone off track, which we see lots of sort of strange things embryos have done since we've had time lapse. Things like instead of going from 1 cell to 2 cells, they go from 1 to 3, or they go to 2 cells and then back to 1 cell, and they do all sorts of things like that. And those embryos wouldn't be the ones that would be most viable. So we're looking for all these different stages of development and all the different parameters that the embryo should do as it works its way through the 4 or 5 days that we have it in the lab. But we're essentially looking at those embryos constantly, and at the end we always review everything, the whole video of the embryo, to make sure that everything has happened properly for that embryo, to make sure we're giving the patient the best chance and the embryo that's most likely to get them pregnant.
The good ones are the only ones that are being transferred. So what is the reason that some might not make it? I mean, is it's just the way it is? Is that the answer?
I mean, there's lots of reasons. I mean, not every egg is created equal, and neither is every sperm. So, I mean, the egg and the sperm coming together, I mean, that's just the very first stage of an embryo's development. And when you think of all the things that have to go right for a sperm and an egg to become a baby, to become a human, it's unbelievable. I mean, all the things that can go wrong along the way. It's amazing any of us are here in the first place.
It really is. It amazes me.
Yeah. So, I mean, look, the vast majority of embryos that don't make it, usually it's a chromosomal issue. Usually it's an issue with the cell division. And instead of the chromosomes developing normally and being duplicated in each cell, something happens and they become what's called aneuploid. And then that embryo just, it almost filters itself out of the pool. It just stops developing, and the cells start to break down so that it doesn't implant and give a pregnancy that's a problematic pregnancy, a pregnancy where the baby's affected. And that happens in the vast majority of these aneuploidies, so when the chromosomes are not present in the correct numbers. And that's another thing that we've got as a tool now. We can actually take a small biopsy of the embryos and send that off for genetic testing and check that the chromosomes are normal in those cells. And again, pick the embryos which are most likely to get the patient pregnant with that additional tool too.
So when it comes to frozen embryos and fresh ones, is there any advantage to having fresh over the frozen ones?
Not really anymore. Certainly 10 years ago, I would have said yes, have a fresh transfer. We're certainly moving away more towards frozen transfers. And in fact, there are some clinics that would only do frozen transfers. They don't do any fresh transfers at all, because there's some evidence out there that the stimulation protocols where we generate the eggs, it doesn't necessarily give the best environment in the uterus for the embryo. So I'm a little bit more on the fence on that. I think one is as good as the other. With our new freezing protocols that we've had recently, it's called vitrification. We would have about 98% of all the embryos surviving. In days gone by, that would have only been 70%. So you were losing 30% just in the freezing and thawing process. Now, we're losing less than 2%, hopefully, which is the biggest risk. So if they survive the freezing and thawing process, the embryos frozen are just as good as the ones that are fresh, if not better sometimes for some patients.
And presumably some people, if they have some good embryos left, they will freeze them for later down the road.
Oh, 100%. I mean, we're looking to, people think that when we do an IVF cycle, we get all these eggs and we're wasting them. In a natural cycle, a woman will sort of have lots of eggs that start to form, and one becomes a dominant follicle, and she releases that one egg. In IVF, all we're doing is we're pushing along a few more of those in order to get a bigger batch of eggs to work with. So when we get that batch of eggs, if we have ideally, say a batch of, 10 eggs, we'd hope to get maybe 3, 4, 5 blastocysts maybe sometimes, and absolutely we would freeze them. I mean, we used to have, I'd say, when I first started in Ireland, we would say that our patients had an average of about 2.3 cycles to get their pregnancy. Now that's closer to 1.1, which means that we're getting more embryos, we're better at getting more embryos, good quality embryos out of the first cycle, and freezing them and thawing them means that the patients don't need to come through for another full cycle again, because they've already got, a lot of the patients at least, have a pool of embryos frozen for the future or for repeat cycles.
Yeah, great. Yep. Can I ask you, do many people opt for the genetic testing to find out if it's a chromosomal issue?
It depends. Some clinics push it more than others. In SIMS, we have about 30% of our patients, I would say, that are going for genetic testing. Now, that's genetic testing of the embryos I'm talking about, rather than genetic testing of the patients themselves. And what they're looking at is, as I said, they're looking at the chromosomes and making sure that those are in the correct numbers in the embryo. We've also got got a new process that we're starting to roll out in our ski clinic in Dublin, whereby we are looking at patients and helping patients where they've got a genetic condition. Either they've got a child who's affected by a genetic condition, or they've got a history in the family, and we can look at the embryos and try and screen out the genetic disease by picking the healthy embryos. And that's something that we're just starting out this year now, and we've got a few patients lined up for that. So yeah, I mean, there's about 30% of patients that are looking at the embryos and looking at genetics of those as they go through their cycles.
So presumably then, if you had a child before who had an issue, a chromosomal issue or something like that, is there a good chance that could happen again because it's the same egg, the same sperm?
It depends on what it is. I mean, most conditions are what we call recessive. So basically, if the parents aren't affected, that means that we each carry two genes. Of every gene, we've got two copies. So if the parents are carriers, that means that they've got one normal copy and one affected copy of that gene. Now, what that means is they've got about a 25% chance of passing on both of the affected genes to their child. So there's a 1 in 4 chance of having a child who's affected. There's a 50% chance of having a child who's a carrier, and a 25% chance of both of the normal genes being passed on to the child. So obviously the embryos that we're trying to not screen out, but look for embryos which are not carriers of both mutations, so they're not going to have that genetic disease. And we're only allowed to do that for serious genetic conditions. I mean, it's not done for absolutely everything. It has to be a single gene condition, because we can't do things, there's only certain amounts that the technology allows us to do so far. But certainly it's something that's becoming more and more common nowadays.
And Graham, when it comes to the transfers then, is it 1 or 2 transfers, or does that depend on the patient, or do they get to pick how many transfers they would like?
We in SIMS would always be recommending a single embryo transfer for the vast majority of our patients. The only patients that we would usually discuss putting back more than one embryo, it would be patients where they've had recurrent implantation failure, so they might have had a couple of cycles where they haven't had any success, or patients who are a little bit older where we know that the embryos are not going to be as good quality as those of a younger woman's embryos. So let's say somebody over 40, the doctor may discuss that. But usually on a first cycle, regardless of a patient's age, we're recommending putting back one embryo. People think twins are ideal sometimes when they walk up the driveway, but I mean, it's a much more stressful pregnancy for the female to carry, and there's also a higher chance of miscarriage. I mean, twins are the absolute maximum number that we would be okay with, but our real goal is one embryo, one healthy baby at the end is the ideal situation for us.
How on earth did that lady in the States, the Octomom, how did she have 8 children? Who allowed that to happen?
A little bit of an unscrupulous doctor, I would imagine. I don't know the full details, but certainly that would never happen over here. The one thing that can happen, and this has happened to us in the past, is embryos can divide, and so if we put back 2 embryos, they're fraternal twins, so they're you can have a boy and a girl, but those embryos can also split into identical twins. So we have had a case a number of years ago now where we put back 2 embryos and the patient gave birth to 2 sets of identical twins. So, there is a chance that the embryos can divide and do things that we were not expecting them to do once they're transferred. So, again, that's why we're looking at one embryo, one healthy baby. If it does split into 2 and we get twins, then, identical twins, then there's not much we can do about that. But we were putting back 2 embryos and that was to happen, then you get triplets, which, again, there's a significant chance of miscarriage then with triplets, especially in any higher order multiple pregnancies. So, it's just not something that we're aiming for.
And then finally, Graham, from start to finish, so say from where you do the egg retrieval and the sperm and all the rest, and you get your hands on this in the lab, from that stage till the end, till the transfer, then how long does the woman have to wait before she'll find out whether it has worked or not?
IVF, it's a bit of an attrition. You wait to see how many eggs you get, you wait to see how many fertilise, how many embryos are good quality, how many you've got to transfer or freeze. But from the day we do the transfer, if we're doing the transfer at blastocyst stage, which is the day 5 transfer, the woman can do the test about 12 days later. We know 100% that our patients test early. They're desperate to know. So there's a vast majority that won't manage to last that long. Yeah. But the one thing we always say to them is that if you test early and it comes out negative, test again and don't get too disheartened, because you can't just be testing a little bit too early. So it's about 12 to 14 days after the transfer is when we know for sure. Then what we do is about 4 or 5 weeks later, we bring the patients back in and we do a scan. And at that point, fingers crossed, what we're seeing then is we're seeing the the sac that the baby's growing in, and we can see a fetal heartbeat at that point as well. And then that gives us a lot of confidence that that pregnancy will be ongoing. That's the point where we discharge the patients off to an obstetrician, and they then get looked after by the obstetrician.
And you'd know at that stage, Graham, if it was a single pregnancy or twins, would you?
Yeah, absolutely. Yeah, that scan between for us, when I say it's about a 7 week, 8 week scan, right. And at that stage you can see we can see whether it's identical twins, we can see whether it's twins, and we can see whether it's a singleton. The fetus, the baby's still tiny. They're smaller than the size of your pinky at that stage, much smaller than that. So it's not something that we're seeing any kind of great detail on, but you can see the fluttering of the heartbeat, and that's the moment that we're all hoping for and then wishing for our patients.
What an amazing job you have. I would love to be a fly in the wall, because I'm sure you get bad days and then you get great days as well, where everything has worked and you've got good news to share with patients.
It is. I mean, look, obviously the bad news is awful. Having to pass on the bad news of, things not going well, that's awful. But then the positive days when things have gone well and we do get the pregnancies, they thankfully outweigh the poor days. So, it's a bit of a roller coaster of a job, but it's certainly interesting, and there's never a dull moment. It's different every day, and every patient's different, and that's one of the things that we pride ourselves in SIMS. We kind of tailor things to patients to make sure we give them the absolute best chance that we possibly can give them.
Nobody has the same story when it comes to IVF. Everybody's so different. No. And you know the way you hear these stories about, Mary down the road did it and it didn't work for her and she spent X amount of money. And then you hear somebody else who's had great success. So it really is so individual. You just never know. Sure you don't. You
never know. I mean, one of my first patients that I got to know really well when I first moved over to Ireland, and that's 20 years ago now, they'd had multiple cycles. They'd barely made it to transfer. And we'd actually told them, look, you should stop. This isn't going to work. At that point, we didn't do any genetic testing in Ireland. So we were referring them over to the UK, and they said, look, please let us just do one more cycle. For whatever reason, whether it was the way the wind was blowing, the moon was shining, we don't know. They got a lovely batch of embryos. I think they got 4 or 5 embryos. We transferred 2 at that point, and they got pregnant with twins and had twin boys. So, and that was a couple where I would have said they had about a 5% chance. So you just never know. As I said right early on, every egg is different, every sperm is different, every cycle is different for a patient. And so not just between patients, within the same patient, everything can be different on any given cycle. So, it is different for everyone, but it can also be different from cycle to cycle for the same patients as well.
Yeah. All you need is one good egg, isn't that it?
Oh, look, we wish we had the technology now to just stick one egg and one sperm and be able to say, there you go, that's it. And that's the ultimate aim for any clinic. We're not quite there yet, but, things are advancing all the time, and we are getting there. I mean, artificial intelligence now is starting to help us as well with picking the embryos. We're now letting it look at videos of embryos, and it's seeing things that we don't necessarily see as a human. So the stuff that's missing to the human eye, it sees. So look, again, the technology is advancing in significant strides. So, hopefully that means that we can get more patients pregnant faster as well.
I'm just thinking, Graham, over the course of this interview, you've probably had about 2,000 images taken in your lab there with the time lapse. Isn't that kind of incredible, the thoughts of that?
Oh, I mean, it'll be more than that, because we've got 4 of those incubators running, and every time it takes a picture of an embryo, it takes a picture through 11 different focal planes. So the numbers are huge, and that's why the artificial intelligence now is something that is starting to come to the fore, because I'm told the human brain can process about 20 to 20,000 different things as you make a decision. You don't know what those 20,000 different things are, but that's apparently how many things are floating through your head when you make a judgment call on something. And of course, the AI computers don't have any such limitation. They're looking at millions and millions of things at the same time, computing what's important and what's not. So it's another tool for us as embryologists to help us pick the best embryo to get you pregnant. Embryologists are very good at picking embryos which are not going to get patients pregnant. We can say, look, that one's not good. We don't think that one's going to work. But if you give an embryologist, or you give a batch of embryologists a group of 5 beautiful looking embryos and say which one's the one that's going to get the patient pregnant, that's where you get a different decision from maybe every single embryologist, because we're picking the one that we think is the right one. And that's where the artificial intelligence and the morphokinetics and all these things that we're using now as tools to help us choose come into the fore, because they're the ones that are independent of our thoughts. So we get a score, and then that narrows down the field of embryos to maybe this is the one that's going to get the patient pregnant fastest.
God, you're so
lots of exciting things going on.
Amazing, amazing. So there is Graham Coull, Group Scientific Director at SIMS IVF. Thanks so much, Graham, and we'll chat again.
Thanks very much. Talk to you soon, Trina.
Fertility Friday on Ireland's Classic Hits Radio with SIMS IVF. Find information and resources that can empower you on your reproductive journey. Fertility testing available with 6 clinics nationwide. See sims.ie.